This is a recording for the newest or the young two-way radio technicians, the ones who are new to the field, and for the ham radio people who want to experiment with different type of antennas to get better range, better coverage. And I'm going to show you two types of antennas I've used today. And after some testing, I realized that for this particular application, for a tall tower, actually two tall towers, 40 stories tall, this antenna performs way better, but it's still not the best solution for this site. But with available materials I had in my service car, that's the best choice. These two antennas are two different antennas, different technologies for different applications, like using a Tesla car for the city drive and using an off-road Jeep for driving off-road and climbing boulders and stuff. So different applications require different antennas. This is a half-wave antenna. It's considered a gain antenna just because the radio frequency is being spread out on a different radiating pattern. So that's where you get a better signal from horizontal space. When they tell you about the donut shape of the radiating pattern, you need to think of a fat donut. A fat donut is going around this antenna 360 degrees, and when I compare it with a quarter wave antenna which has no gain, that one is even fatter donut. So it's like except to the top, to the vertical, you have coverage including the above the antenna. So it tells you that that antenna is spreading signal all over the place, less at the bottom beneath the antenna and less at the top, right above the tip of the antenna. When this antenna has narrower donut, that means the signal is more concentrated, shooting far. Now for this application we did not need to use this type of antenna because the site is not that far but is high up. So we needed to use the quarter wave antenna that also is shooting up, but lots of signal is getting wasted behind and sideways. So that's a waste of radio frequency energy. Now if I compare to a sprinkler head, if I look at the sprinkler head here, some of those are adjustable, but most of them are spreading water 360 degrees, and some are able to adjust the pattern to spray upwards and sideways. But that's the same idea here. You want that pressure that coming from the transceiver. In this case it's a radio repeater which I installed down at the bottom of this vent shaft. So you want that radio frequency energy, which is like a pressure on the water systems. You want all that to go where you want to go. It's like you don't want to waste water. If you adjust that sprinkler head to spray 360 degrees, you don't want water on the rocks. You want water only a certain area, so you probably need to adjust the sprinkler head instead of replacing it with a different type. Same thing here. You don't want the water to be sprayed here on the gravel. You want the water to go only on the dirt to feed the plants. So in our case, we did some tests while the building were not that tall. It were like just halfway, and at that time we got good signals, so we decided to go with the minimum materials here, and we use this antenna. But now the buildings are 40 something stories tall. There are two buildings, one next to each other, and they complain that they cannot get signal in certain hallways to test some of the systems. And today I got here, one cable was pinched. Same idea with the hoses. If you have a garden hose and if you want to water your plants, if the garden hose get kinked and pinched some places, then you don't get enough pressure at the water hose head or the sprinkler head or that watering handle. Same thing here. If you have a pinched cable somewhere or even a bad connector, then you lose that pressure, the energy that travels through this coaxial wire gets lower, and you cannot have enough radio frequency to travel all the way to the other radios. Now, we've done some testing after I repaired the cable, and still was not enough signal to penetrate some of the thick concrete walls these buildings have. And I decided to grab an antenna that I had a spare antenna on the service van. And this one is not the perfect antenna for these sites, and being this close to the buildings, to the two buildings, an antenna that has 3 elements only would be a better choice. So I would have some signal shooting sideways, but not that much. So sideways it would be a waste. Some signal shooting backwards, which is another waste, but it won't be that much of a waste when compared to that antenna. And now, because this Yagi antenna are designed to be directional antenna, and this particular one has probably about 7 dB gain of signal gain. It's like more than double and double, and more than 4 times of the gain. So 3 dB is double the gain, 6 is another doubling of that. So this is it's a pretty good antenna for long range application where you want to direct all that energy towards a smaller direction. So this probably has like a 30 degree, I'm not quite sure. This is an older antenna, I just found it in the car, or I had it in the car. It could be like a 30 degree, like that and like that. So you have a spraying, you have some radio frequency spraying sideways, and these people rely on bouncing signal from those side buildings and other structures here, but it's what works better. After they did a bunch of testings today, the signal got way better while using this antenna. In some areas they could not get through. With this one they said, yeah, it's all we need. So I'm good to go back to the office and do some other bench repairs. Like I said, with a 3-element antenna only, I would waste maybe on 45 degrees sideways some energy, but I would get more energy to the top when compared to this one is shooting more to the bottom and to the middle. So it's going to be more energy than needed to the mid bottom and less to the top. And I could aim this one, I could aim it somewhere to the middle. I could do that, but since they've done the testing and they are okay with that signal level, then I can go back. Yeah, so I had to use some sort of a contraption. This is a temporary setup. They are going to use this one until they finish. They already today they talked to the homeowners. So lots of people got in here to see what they are buying. So it's almost complete. Almost complete. So in probably a month or two, this building will allow the homeowners to move in. It's a very organized system. Even the moving in is very organized system. And then someone is coming back here to remove the antenna and send it back to us. So this antenna, it's just spare. I don't want to start pulling cables because it's a long cable going from the ground floor to 7th floor down. So it's a long cable. I don't want to start taking the cable which is being used as an anchor for the newer cable. So that's the basic idea about the difference between the two antenna. One antenna got signal all the way to the top in the both buildings of 44 or 45 stories tall, and the other antenna, which is not meant for this type of application, is meant for radiating 360 degrees, did not get the signal in many places, many areas at the top of the building. So yeah, that's the idea I was trying to share. Talk to you later. Bye bye.